Hello friends, welcome back. In this video, we'll discuss how to do panel regression in Stata. This is my part 2, the part 1 and basic video I have uploaded earlier. You can go through that if you need some basics for that. Here I will show how to do fixed effect and random effect model for panel data in Stata. Friends, here I am mentioning only commands how to use. If you want to know why to use fixed effect and why to use random effect, that is one other video I have made. You can go through that. Here I have simply shown how to use fixed effect and random effect, how to use the commands for that in Stata only. Okay, friends. Uh, Here, friends, first of all, we need to import data in Stata. The simple command for importing in Stata is you can write by this is the command, or simply you can import by the function you have earlier, by import function here, file, and then import an Excel sheet. In this way, both are same. You can do whatever you want. So suppose I have data. So if I want to see the data, I can go. If you want to see the data, you can go this data editor and see. Uh, First variable is cross section. That is my country variable. Then my year variable. Then my other variables are GDP, capital, labor, teledensity, and their logged values. So here, friends, I have six countries: Bangladesh, Bhutan, India, Sri Lanka, Nepal, and Pakistan. And for each company, I have data for the period 2001 to 2013 for these four variables and their logged values. So now I want to do fixed effect and random effect regression for them. How to do that in Stata? Uh, First of all, friends, here I need to show here the country variable, that is a cross section variable, is a string variable. But for running regression, we simply need a numeric variable that gives a certain identity to them, like for Bangladesh 1, for Bhutan 2, in this way. So in Stata we have one command for that purpose. Simply we can do this. We can generate one more variable, country 1, by usingegen command. This command is egen for generating something special, like egen country 1. This is my new variable name. You can give any name. Is equal to, you are grouping the country variable. The names of the countries are in country variable. So I am doing egen new variable name with a function of that is grouping countries. uh, so now I have new variable country. If I see at that, the new variable, this is country new variable I have generated. That is 1 for country first, 2 for country second. In this way, for all of them, six countries, six variable I have generated. This state I have generated, friends. So now we are having our data with us. We have generated identity for a country. Then we need to tell Stata that the data we are having is a panel data. So for that purpose, we have to tell Stata that which is cross section ID and which is time series ID. For that purpose, we are running a command. We will first use xt set command, then we'll give cross section id, then time series id, and by putting comma we'll mention a frequency. Is it yearly, it is monthly, is it quarterly, and it will instruct Stata and declare our panel data. Okay, friends, I have already written to save our time. I am simply mentioning here using xt set command, that is setting my panel data. Country 1 is my cross section variable that contains 1, 2, 3, 4, 5, 6 data for countries. Then year is my time series data. Yearly is my yearly frequencies I have for each country for each time series. Enter. So now if I just look at the results, it is showing me it is a strongly balanced panel for the time period 2001 to 2013. Okay, friends. So now we have declared our time series. Now we simply can see what is summary of my data. So suppose I am having only two variables for ease of explanation. The first variable is ln GDP per capita, And second variable is tele density. Okay friends, so now something is wrong here. GDP and oh, xt set, no, here I have to xt sum. Earlier we used sum command, sum, that is short for summary. Xt sum is command for summary of panel data. So in this panel we are having only two variables, ln GDP and ln density, and this is our mean, standard deviation, minimum and maximum, and number of observation for overall. Like for 70 observations we have for 6 countries. Uh, so for each country 13. So 13 into 6, 78 observations for that mean and standard deviation is there. And suppose here friends we have three things overall 478 between the groups for the 6 countries, and within the group for each group we have 15 observations. So here the standard deviation is for that specific group for 13 group, in this way for both of them. And then we will go for fixed effect and random effect. So here the command for fixed effect and random effect is uh, xt. Simply we use regress command reg, but here we will use xt. For every panel data command we will use xt as prefix. So xt reg, then our dependent variable followed by independent variable comma, and we will give the caption like fixed effect के लिए fe for fixed effect. Okay, so what is our dependent variable here? I am simply saying dependent variable is ln uh, G, GDP per capita followed by ln tele density. Then I'm saying it do fixed effect, run fixed effect. It is doing for me. So now after controlling for fixed effect like intercept dummy for each country, this is my regression result that tells me number of observations 78 observation per group, minimum, maximum, and the p-value for the overall model is 0.00, which says the model is highly significant. Coefficient for the variable, here we can see probability for teledensity. The independent is very high, means teledensity plays a significant role in GDP. Uh, and This is the way we can get variables for them, results for that. So now friends, how to do suppose this is the fixed effect, but there might be a chances like this fixed effect, the coefficients we are getting here for tail density, they might be affected by heteroscedasticity or autocorrelation. For that purpose we need to do some correction. We need to find robust errors for the coefficient. So how to do that friends? It's very simple in the Stata. Here we are, the earlier command we use, now what we are adding additionally, we are simply putting one more thing, VCE robust, VCE robust, and then running it. So now we are having one more regression. Coefficients would be same. Here the coefficients we are getting for variables, independent variables would be same, but the error part will change. We are getting some robust errors. The coefficients are still significant. And this is the way we can find robust errors. Those take care of autocorrelation and heteroscedasticity in the observations. So this is the way we can do fixed effect regression. Now we come to random effect. How to do random effect? So friends, and the for fixed effect we are having acronym FE. And how simple it is, we will use RE for random effect model. Now it's run. Interpretation is as same as we do in our simple regression. So this is the way friends we can use fixed effect and random effect model in Stata. Well, and one more thing I need to show mention here friends, when we do random effect model, Stata use GLS method as usual. Simply for random effect we have to use GLS method, and it does the calculation for the coefficients. Uh, this is the way, friends, we can do fixed effect and random effect. Thanks for watching. Keep watching. In next video, I will show how to do Houseman test just to select the model. Whether we should use fixed effect or random effect, which model is more appropriate for our data. We could do one test, that is Houseman test. So how to conduct the Houseman test? Please see my next video doing Houseman test for selection of appropriate model. Thanks, friends.